Hi, welcome back to another OCR MEI past paper walkthrough. Today we're doing the 2017 C4 paper. So this paper is, as usual, out of 72. And it also includes a paper B with comprehension, which I will not go through with this part of the walkthrough. So let's get right into it. Section A. Express 5 minus x over 2 minus x 1 plus x in partial fractions. So actually doing partial fractions aren't that difficult. There are always a certain pattern that you can follow, and this is a very typical one. With two brackets at the bottom, you just state that the previous partial fraction should be in the form of a over 2 take x plus b over 1 plus x, which will equal to the given value shown. So by multiplying the bottom by the two brackets, I'm just a bit lazy to put that in, you should get 5 take x is a lots of 1 plus x plus b lots of 2 take x, which will be useful because if you substitute x as a value of -1, then you should be able to obtain a value of 3b equals to 6, which gives you b equals 2. Similarly, if you take x as 2, you'll be able to cancel this side so that you'll get an equation of a, let's see, that is 3a is equal to 3, which means that a is 1, and therefore your partial fraction should be 1 over 2 minus x plus 2 over 1 plus x. So that's the first part of question 1 done. So part 2 involves using binomial expansion to express this whole term in terms of ascending powers of x, which should be doable if you give enough thought into it. So first of all, let's express this in terms of a power series, which is equal to 2 take x to the power of -1 plus 2 lots of 1 plus x to the -1. And for this one, you can't actually do binomial expansion because of the 2 in front, which means that you need to take a factor of 2 to the -1 out. 2 to the -1 times 1 minus x on 2 to the -1, add 2 lots of 1 plus x to the -1. So with this in mind, we can now start to do expansion around these two brackets. You need to make sure you do not lose the first term. So to expand this, it would get you the first term as 1, then add n, then the unknown term, then the second term, the third term would be n times n minus 1 all over 2 to the factorial, which is just 2, times the unknown squared, and this goes on, but it doesn't matter because we're only going to the first 3 terms. Same thing for the second bracket. You get 1 plus n lots of the unknown, add n 1 times n minus 1 log over 2 factorial of the unknown squared. Again, it goes on, and it doesn't matter. Now with this in mind, we can start to combine these two lots. So by putting in this value, we get half plus x on 4 plus this cancels, and we have 1/8 of an x. Make sure you don't forget about the 2 in front. Lists goes on, then you add the second terms, so we get 2, take 2x, add 2x squared, keep going, and now we can actually add the like terms. So half plus 2 gives me 5 halves. Then we take away 2 from a quarter, which will give me 7 on 4, minus 7 on 4x. And 1/8 plus 2 will give me 17 on 8x squared. I missed the square here. And it goes on, but it doesn't matter. That's all you need to find. So that is a 5 mark for you. Question 2 is a factor classic question. So part 1, find the coordinate of the point of intersection of the line and the plane. The line is defined as r equals to -1, 0, 1 plus lambda lots of 2 minus 3, 1. And the equation of the plane is 3x plus 4y minus z equals to 17. What you need to do is to express r in terms of the x, y, and z coordinates. So the x would be -1, add 2 lots of lambda, y would be equal to just -3 lambda because it's 0 in front, and z will be equal to 1 plus lambda. With that in mind, we can substitute into this equation to get -3 plus 6 minus 12 lambda minus 1 minus lambda equals to 17. So you can just see that I have explained everything. And now move the 4 to the right, get us 21 on the right. 6 lambda minus 12 lambda minus lambda gives me -7 lambda, and so we know that lambda has to be -3. With that information, we can substitute this lambda value into the line equation to give us a single point, and that would be the point on the plane which goes through R. So we have -1 plus -3 lots of 2, which is a -6. Then on the y, we have just -3 lots of -3, give me a +9. And for the bottom, we have a 1 plus -3 as my x, y, z coordinates, which will eventually give me -7, 9, and -2. And so that is the solution to the first part of the question. Second part of the question, find the acute angle between the line and the normal. So the equation of a plane normal is just the prefix of the xyz value over here. So the normal factor would be a 3, a 4, and a -1 for a plane. And the line factor is the prefix of the lambda, which is a 2, -3, and 1. So with that, these two factors, if we take a dot product between them, we will get the angle cosine theta, given that we divide the magnitude of the two factors as well, or these two factors. So the magnitude of this factor is 3 squared plus 4 squared plus 1, which will give me 25 plus 1, 26. For this one, it is 2 squared plus 9 plus 1, which gives me 14. And put the dot constituents will give me 3 times 2 is 6, minus 12 gives me minus 6, then minus 1 is minus 7. So we get minus 7 on square root 26 times 14. Put them all into the calculator and you should be able to get that theta is 111.52 degree. Note that we want the acute angle, which means that we need to take this value of 180 in order to find a smaller angle, which should be 68.5 degrees, rounded to 368. Question 3 is a good old typical trapezium rule question. They are quite grindy, but it's usually 3 marks, so it doesn't really hurt to actually know how to do them. So part 1, explain whether T4 is greater than or less than T2, where T2 and T4 are the trapezium estimates of the value of the area under the curve. So note the fact that the gradient of this curve is constantly increasing, which means that when you take the trapezium rule estimations, it will be an overestimation. So first states that it is over estimation, and using that information, we know that the less strip you take, the less accurate or less true the value is. So T2 is further away. Then T4 from true value. And so with that in mind, we know that T4 is more accurate, T2 is less accurate, and both of them are overestimations. So the logical deduction would be, therefore, T2 must be greater than T4. And that is part 1, explained, because remember you need to explain, so use word, don't use numbers. Numbers wouldn't help. And part 2, evaluate T4 using trapezium rule, because T4 is the estimate obtained by trapezium rule. Do not try to integrate this. This is just going to be really, really nasty. So trapezium rule with 4 strip of equal width, it's gonna be of value -1, -half, 0, a half, and +1. Make sure you do the table, by the way. It often saves you quite a few marks, even if you did the wrong numbers, then you put it into the wrong to the equation, turns out the answer is not accurate enough, then you have some marks to salvage on. So the values, after you've done the calculations, I've done this beforehand, this is because this is actually quite painful. You should be able to get these kind of numbers. All of them are to 4 dPs for just for no reason, really. So using these numbers, we can use the equation half, let's see, half of the width of the strip, which is 0.5, multiplied by the outside numbers, 1.0655, 2.8964, then add 2 lots of everything in the middle. That's the shortcut way of doing trapezium rule. I just used root 2 because I did the algebra and it kind of worked. So you can use 1.41, whatever that is. It's still gonna be fine. The accuracy isn't the biggest deal in this question anyway. So after you've evaluated this whole value into the calculator, and if you didn't press any button wrong, you should arrive at a value of 3.25, and that is the correct answer for part 2. Question 5, it's about trigonometry. Typically there will be a 1 on trigonometry anyway. It would be something to do with double angles. It's actually quite straightforward. So quite unusually, they decided to take the tan 2 theta root, and I'm pretty sure these equations are in your formula book anyway, so it's gonna be quite fine. So if you expand tan 2 theta, you get 4, you have to keep the 4 tan theta in the front, multiply that by 2 tan theta over 1 minus tan squared theta, and that equals to 1. With that information, we can multiply both sides by 1 minus tan squared theta and simplify the left side to 8 tan squared theta equals to 1 take tan squared theta, and rearrange to get 1 equals to 9 tan squared theta, and by rearranging again and taking the square root, you get 1 over 3. Remember, it is a plus or minus because we took the square root sign. Square root sign are basically the full mark killers of the core modules. Just make sure, if you are the A-star student, do not forget this. If you're just if you're failing, then don't even worry about the plus or minus. Just try to get as many marks elsewhere or something. Of course, these are easy marks to get as well. If you can remember it, do so. Plugging these values into the calculator gives you theta equals to 18.4 degrees, and it's also from the calculator minus 18.4 degrees if you use minus a third. But we can't use this value because this is out of range, which means that we need to add 180 to that, which gives us 161.6 degrees. Make sure you state which unit of angle you're using. If you want to, you can use radians, but do denote it, because they will penalize you for using the wrong numbers. So question 6 is the last question of the section A, and it's about the E, and it's quite straightforward. It's only 1 and 3 marks worth. And these are easy marks to pick out, but if you actually can't do the exam, if you feel like you can't do the exam, then you could possibly forfeit this, but I do not recommend it. It's so simple. It's 3 marks. Let's see what we can do here. So the number of bacteria in the population at time t is denoted by p, and the rate of increase of p is proportional to the square root of p. Write down a differential equation relating p, t, and proportionality k. So from the question itself, we can see that the increase of p is proportional, so let's start with the proportional sign, to the square root of p, and the rate of increase of p. Rate implies time derivative, so dp by dt is proportional to root p. With that in mind, if we turn it into an equation, which means we need equal signs, will give me k root p. So that is 1 mark in your pocket. Then verify. Basically, do not try to solve this, it's not worth it. Even if you do DE, it's not worth solving this because they gave you a solution. So let's just differentiate a plus bt squared. So dp by dt of that is just, we need to use chain rule, which means that we drop the power and u is a plus bt. Power goes -1, 2 minus 1 is 1, so I just leave it. Then you need to multiply by du by dt, which is just a straight b. So you get 2b times a plus bt. And guess what a plus bt is? To our surprise, not really. It's just root p. And so we have a satisfactory solution. dp by dt is 2b root p. It's proportional to root p, and k is 2b. Make sure you write this down or you won't get the mark. And that's all for section A. Hope you learned something, and I will see you on the next one, which will cover section B.